Hi, welcome back to the channel. In this lesson, we'll see how to calculate voltages and charges across capacitors. Then we'll go to simulation where we'll see a practical demonstration of these voltages on Simulink in MATLAB. That said, let's get into class. From this circuit, we have two types of capacitor. We have a set connected in parallel and we have the set connected in series. The first thing I want us to do is to see how we'll break down this circuit. This circuit, here is my C1 again, here is C2, here is C3. Obviously, C1 and C2, they are connected in parallel. We'll merge together to form my CT here. Now, remember that when capacitors are connected in parallel, we'll say that my C3 or my CT will be the same thing as C1 plus C2. So that my CT in this case will be the same thing as 3 plus 5. That gives me my CT to be equals to 8 microfarad. So that in place of CT here, I can have 8 microfarad. Next is to now see what happens between my 2 microfarad and 8 microfarad. My CT, we have seen it to be the same thing as 8 microfarad. Now, but when capacitors are connected in series, we'll say that my 1 over CT here will be the same thing as 1 over C1 plus 1 over C2. And my 1 over CT obviously is the same thing as 1 over 2 plus 1 over 8. Both of them are in microfarad, so let's just walk this way. This is 8 as my LCM. 2 in 8 is 4. This becomes 4 plus 1, which is the same thing as 5 over 8. That if 1 over CT is 5 over 8, obviously my CT should be the same thing as 8 over 5. So that this implies that this is only at 1.6 microfarad. So the effective capacitance in this circuit is 1.6 microfarad. Now the next thing we'll be thinking of is to calculate the charge dissipated by this voltage source. Now remember that my Q is equals to CV. Now, if Q is equals to CV, that is the effective charge from this voltage source will be the same thing as Q, so equals to C, that's 1.6 times 10 raised to the power minus 6 times 100. That's the same thing as 160 microcoulombs. Charges are measured in coulombs. Now, if this is 160 microcoulombs, that means my 160 microcoulomb will flow through this circuit across these 2 microfarad. I have 160 flowing to this point. Across the combination that gave me 8 microfarad, we have 160 flowing into this point. Now, let's calculate the voltage that is dissipated across each of these charges. Now, we have gotten our charge to be 160 microcoulombs. Now we can begin to calculate the voltage dissipated across each of the capacitors. So that across this, let's tag this as V1 and let's tag this as V2. Now, if my Q is equals to CV, this implies that my V is equals to Q over C, which is the same thing as 160 times 10 raised to the power minus 6 over 2 times 10 raised to the power minus 6. I'm left with 2 here also is 1. Here is 80. So that my V across that's V1 will be the same thing as 80 volts. Now without missing words, if my V1 here is 80 volts, if I have 80 volts here, obviously my V1 plus V2 is the same thing as 100 volts. My V2 will be the same thing as 100 minus 80, which is equals to 20 volts. At 20 volts. So here on my V2, I'll have 20 volts. And here at my V1, I'll have 80 volts. I did promise we'll use MATLAB to physically see these voltages across these capacitors. Now, if you look down here, this is my DC source And if you look here, it's an 100-volt source that was used in the calculation. And here also is my first capacitor, that was the capacitor C. And if you look here, this is 2 times 10 raised to power minus 6, that is 2 microfarad. Here is the C1, and the C1 is a 3 microfarad. And here is the C3, that's a 5 microfarad. Now, each of them will run this simulation for a period of 0.2 seconds to see the effect and to see the voltages that will be dissipated across each of the combination. I've used this voltage measurement device to actually capture the voltage across this particular part of the circuit, while we use this other voltage device to capture the voltage across the other parts of the circuit. Now let's run it. Let's run it to get into it. Now, if you look here closely, you see that here I have my 20. This is 80. Sorry, this is my 80 volts across the 2 microfarad. Then this is a 20 volt here across the parallel circuits. Now, I will not be able to go into details of explaining how to actually put the circuit together, because this is far beyond the scope of this class. But with this, I hope you understand how to measure, how to calculate voltages. With this, I hope you understand how to calculate charges and voltages across capacitors. Thank you, and see you in our next class.